Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology and Autonomous Institution, Coimbatore. In this YouTube video, I am going to discuss about 23 ECET 221 Microprocessors and Microcontrollers under Unit 4 Interfacing Microcontroller for the topic Analog Digital Communication Interfacing. Already I have discussed what is meant by microcontroller and how these microcontroller are constructed and what are these applications in real time, and the design thinking based of microcontroller already discussed. If you need to watch my video, I will share that link in this description. Now we are going to discuss about ADC interfacing. ADC means analog digital communication. An ADC interface system is an microcontroller is used to connect an external analog to digital converter when internal ADC resources are insufficient or unavailable. It acts as a communication bridge between the microcontroller and the external ADC, enabling conversion of real-world analog signals into digital data. So the main purpose of analog to digital converter in microcontroller is it gets the input in the form of analog, getting the input in analog sine waveform or square waveform, and converted into digital pulses of zeros and ones. So the main components in this analog to digital converter are: one is analog input channels, data bus, control signals, that is start, EOC, OE, CS. Start means we can start the program, EOC means end of conversation, OE means output enable, CS means chip select, then finally it is the external ADC module. This is the interface circuit where how can we connect this ADC to a microcontroller. Here, as I told earlier, analog input is the input which is getting from either a sensor input or some sine wave. The output which we connected this analog input is the form of microcontroller. Our concept of ADC converter is here only, that is this orange color. So whatever the input sources, first this analog input is given to ADC. This ADC is an electronic device, so it needs some power supply. That power supply is given by reference voltage and some clock signal which is given for time conversion. Then the output is given into the data bus, and if microcontroller wants to send some information to ADC, they will send that information to chip select, then read module, then start and startup conversion module. Once this conversion is completed, this ADC converter will send to the microcontroller for end of conversion. So once end of conversion is received by microcontroller, they will stop the current running process and they will halt the entire program. So this is what a normal ADC interfacing will applicable. Next one, how this various signals are carried out by using ADC. First, the analog input channel. Select the analog signal to converter, that is, it is a unidirectional. It's come from sensor. Data bus transfers converted digital data. It also a unidirectional, that is ADC to microcontroller. Next, the START, startup conversion. It initiates the conversion process, that is analog to digital. Microcontroller triggers the analog to digital converter. EOC, end of conversion. It indicates the completion of conversion. ADC signals microcontroller. OE, that is output enable. It allows ADC data to appear on the data bus, used for data read operation. Then finally is a chip select. It selects particular ADC device for displaying their output to the microcontroller. Next, this figure shows the types of ADC interfacing. There are two types of AD interfacing are available. One is called the flash type ADC, then another one is called a successive approximation ADC. If you see the flash type, it's a conversion of high speed, low resolution, and multiple comparators they are used. If you see the successive approximation ADC, it operates in moderate speed, very high accuracy, and it is the commonly used module which is used in analog to digital conversion module. This is the working principle of ADC interfacing. As I told earlier, the analog input signal is applied to ADC, that is analog signal means it is a sine waveform. Second, the microcontroller sends the startup conversion, that is start signal, to ADC. So microcontroller wants to get this information in the digital parameter. Once this digital parameter is completed, that is this ADC converter samples and converts analog signal into digital signal, they send the ADC asset to the end of conversion. Once the end of conversion is completed, microcontroller needs to display their output in the digital medium, so it activates the chip select. Either they want to do the read operation or the write operation. Based on this data bus selection, the output is displayed in the digital output memory or display side. Examples of microcontroller supported external ADC. 8051 microcontroller interfaces with the external ADC using control signals. Microcontroller system uses data bus for ADC digital output. ARM based microcontroller supports external ADC through GPIO or parallel interface. Advantages: high resolution, analog signal conversion, flexible sensor interfacing, suitable for real world data acquisition application. Disadvantages: increased hardware complexity, high system cost, slower than internal ADC modules. This is the mind map where all these topics are discussed. These are the references which I use for preparing this PPT. So in this YouTube video, I have prepared what is meant by analog digital conversion and what are the types, how they are working. Next YouTube video, I will bring with a new innovative topic. Thank you for watching my video.